Good morning. Boom, 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 boom. Bum, 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 bum. Bum, 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 bum. Bum, 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 bum. So, welcome everybody to Voxel Fridays on Saturday. My viewer count just dropped from 45 to 35. That's nice. I wanted to wait for it to get to closer to its peak before I start explaining what we're going to do. But maybe that's its peak because it is Saturday. But I did only give a short notice, so maybe more people will show up over time. I'm not sure. I took a nap between. I pre-announced this on Blue Sky an hour ago, and then I fell asleep, and I woke up 5 minutes before 9, and I could have, maybe I should have started the stream at 9:15 instead of at 9, so that I'd have a bigger lead time. But profile. All right, let's go ahead and switch over. This isn't quite there. There we go. This little where's the bottom? Okay. So I guess we start. So I did some work off stream on this and figured some stuff out. I was able to. I'm able to get more consistent profiling if I'm not streaming because I don't have OBS running. And I'm trying to figure out how to attack this. So we're doing this 4-stage thing, this 3-stage thing here. Occupancy, visibility, meshify. And there's a 4th step. Which we haven't done. we haven't done step 3. We did step 1, 2, and 4. And there were multiple strategies for this, and the one that was written down here was to traverse over the command list again. The one that is written down is to traverse the command list again. There were other possible strategies. And so I did sort of a test run at texturing, at building this big grid of texels. So, all right, the idea is that the command lists that say where to put voxels contain 32-bit texture info for each voxel, well, for all of the voxels in parallel. And when we go to generate the meshes, we need to read out that 32-bit data. But we're generating occupancy and visibility using 1 bit per voxel, because it's very expensive to store the 32 bits per voxel that's needed to include texture data, and we don't want to do the occupancy calculations using that data. But one possibility for texturing is that we go ahead and build that full 256 by 256 by 1024 grid with the texturing data, and then when we generate the voxels, we can read them. And right now, we're only doing steps 1, 2, and 3, 1, 2, and 4, and so we are just putting placeholder textures on instead of the requested textures. And we have this gap because of a thing that I did that we have to address. But, so I tried 2 different methods for this texturing offline. One was for every column, build a span to go through the commands that affect that column and write out a span of texture data for each one. And the other one is this one. This is an old version that I was trying at some point. This one builds the full sparse texture grid, the 256 by 256 by 1024 texture grid. And when I did this, I had a performance problem. Single file for all game codes is okay, sure. It depends how big your project is. But for most indie games, yeah. So the idea is to parallelize over the voxels in a draw call, a command list draw call. So you get a command to do a slab, ignore this if else. This was me trying to figure out the performance things. So the idea here is that you loop over all the voxels. You compute how many voxels are in the slab, and then you loop over all those voxels, but you step by the size of the compute shader work group, the number of SIMD lanes, and then each one figures out which of those sub-voxels it needs. We actually do divisions to get back where we are in the slab, and then we write it out. And this was debugging. And I was doing this, and the performance was terrible. It took like 30 or 40 milliseconds. So I tried, well, let's only write out from the first thread, from the first SIMD lane, not from all of them, and see if that helps the performance. It didn't, so it wasn't bandwidth related, which makes sense. It shouldn't be bandwidth related. I looked at the bandwidth numbers for this old GPU, and it does 300 gigabytes per second, and this is doing a tiny fraction. We're only touching a tiny fraction of the grid. If we touched every voxel in the grid, 1024 by 256 by 256 by 4 bytes, that works out to 256 megabytes. So 4 times a frame, that would be, 4 frames a second, that would be 1024 or a gigabyte. So times 15 is 60 frames per second, would be 15 gigabytes, which is a tiny fraction of 300. So it should be much faster. So I did this alternate loop much simpler to try to figure out what was going on. And it's some kind of loop optimization problem. Because if you remember the find LSB trick that we looked at, where the find LSB version was really slow and the non-find LSB version was fine, we're seeing the same thing here. I force the loop to run at most one time, but the optimizer doesn't see through that and figure it out. If I just set num voxels to 64 here, then the performance bug goes away. But if I do this thing, which makes it only run at most once, and then I force size to 256 just to be confident that this definitely only runs once. I rarely or never, this is a variant of that. We saw there was a thing down here where I had a test to suppress most writes. This is a test to basically suppress all writes. No, this is never true, but the optimizer doesn't know that. So if I break from the loop, which forces it to only run once, then it's fast. But if I don't break it from the loop, we know it will only loop once, but the optimizer is doing something wrong and it was slow. It's 82 in here. I'm going to open a window. Too many computers generating heat or something. So when I hit this performance bug, I was like, well, shoot, maybe I can't do Voxel Fridays. Like, maybe I can't do anything on the compute shader trustworthy. You know, this Windows 7 computer, so it's stuck in an old drivers, and maybe the drivers have some bug. I tested running on my 4090 and the performance was fine. Obviously the 4090 is a lot faster, but it sure, you know, it wasn't just proportionally faster. It was more like the break case here. And so if I run this, this is the third number, the 0.001 milliseconds number, because it's the 4 steps that we were just looking at texturing. It's third step. But what did I call it? Oh, remesh. Let's put it back. So if I take out the break, yeah, no, it's 20. For various reasons. I think it's I think there was a version of this where I had it running the loop, it looped twice or something, and that was when I measured that 40. But also, it's just kind of a little bit unstable. The LSB loop had a condition which was I grading equals 0 instead of I grade 0y. If you call find LSB, it's looking for the least set bit. And if there are no bits set, it returns -1. And so you're looping until the LSB gets -1. The better thing to do is to just loop on that the value itself is all zeros, right? Instead of testing what the LSB was, you should just loop on whether the bit array is zeros. Anyway, so, but it turns out we're just doing this at startup. We're doing this meshing at the beginning. And what I found is if I press, is it V? I may not have this enabled anymore. Yeah. I don't have. I set up a thing. I did a lot of debugging. I was reaching a point of like maybe I can't do Voxel Fridays anymore because we just have too many compute shader glitches. But then I installed an older driver just to check. Maybe some older driver didn't have this bug, and the third mesh number went small, but the first mesh number went large. And I was like, well, great, like that one has the bug now. And I was like, that's kind of weird though. And I kind of became a little suspicious. And so I stuck in a bunch of GL finish calls to make sure I was really only measuring the performance of each thing. And that kind of seemed to change the results. But you know, what's happening is we're doing this at startup. We haven't even page flipped a single time. And it turns out if we just, now I'm remeshing every frame. And hey, look, the times are tiny. And this is with OBS running and introducing overhead. And you can see they flicker a little, which is good. They should. So there's apparently some kind of stable performance glitch or performance measurement glitch when you're running at startup, or maybe we're measuring the cost of compiling the shader for the first time, because when we call compile and link, maybe it doesn't really actually build the final shader. Maybe it waits till you use it to build it, and so we're measuring that. I don't know. I don't know what exactly is going on. But it's kind of funny because it was kind of recapitulating the whole thing of me streaming originally. I mentioned in the first stream that I was trying to figure out how to stream my 2560 by 1600 computer, Win 7 computer, and just could not seem to find any method that was going to be viable for setting up a capture card so it could be off the machine. And had reached this point of thinking to myself, well, I guess maybe I just won't stream. Like, this just doesn't seem feasible. I've been thinking about this and researching it for several days, and I just am not finding a viable method. And I kind of reached this point of thinking, okay, maybe it's over. Like, I'm just not going to do it. And then somebody pinged internet legend Will Smith, and he suggested just streaming in 2560 by 1440. And 2 days later or 3 days later, I've started streaming. So in the same way, I was kind of thinking, maybe I just got to bail on doing compute shader stuff. This is just totally broken. And hey, look, actually, no, the performance is totally great if you just do it every frame instead of only trying to do it once. Now, we used to do it every frame in a very early version of this that was very slow. And since it was very slow, I stopped doing it every frame. But so it's looking good now. Now we're not doing the real version here, so let's switch to doing the real version. I haven't even done this. I don't know how slow this will be. Oh no, we're back to hitting the bug. Oh no, because I haven't turned it on. Yeah, great. All right, so let me just turn it on permanently. Remesh. Okay, so we'll just remesh every frame. We could potentially just remesh twice and not be doing it every frame, but we might as well just do it every frame. So of course this is a very simple thing, and you know the total time is 0.2 something milliseconds. So we're going to hit the 1 millisecond limit pretty fast, even so. But let's check. So there's a bunch of code changes to do this at, just a refactoring, just moved code around so that I can do this every frame. But let's try the other meshing. Make texture runs, the other strategy, which writes a lot less data, and see how that one does. 0.04, and this one was 0.04, I think. They're about the same. Yeah, so might as well do this one that builds the full texture grid. So that means we can potentially read the full texture grid. So where do we build it? We build it here. So let's copy that to Voxel Jobs, mesh from Voxel Job. We need the texture grid and put this at 9 just to have something. That's at 9. Then we say tech equals texture grid of z plus y times 256 plus x times 1024. And then field extract 5. Five, 10,5. 15.5. 25. In theory, that's all it should take, but I'm sure I've forgotten something. Well, it looks different than it used to. I'm not sure why it's got that one stripe, unless I did that intentionally. I mean, I think that's just all zeros. I think we're being zero knitted here, and we're not actually getting the real data. We need to make sure we memory barrier between when we do the textures. Yeah, we do. So we might not be generating the texture grid correctly. We might be reading it incorrectly. Well, we can debug. So let's see. Mesh from Voxel Job is not writing anything to debug. Voxel Jobs from Occupancy. It's not writing anything to debug. Occupancy bit array VRAM. Not writing anything to debug. So we'll see if we'll check that debug is mostly zeros. Yeah, it is. Okay. So let's change it so that make texture runs at the end. Oh, not make texture runs, the other one. Build texture grid at the end. Is going to say, do we do 8x8? We do 8x8. Okay, so we can say we can use pause. Debug data of pause dot y times 256 plus pause dot x equals texture grid of 25 plus y plus x times 1024. So we can see what texture we're storing in the 25th Z level. x. Okay, here it is. I want it 08421. What are we writing into it? That's in our commands. What's lab 2108421? So we are writing out the right value. So we're either not reading it correctly or we're not using it correctly. 8421 and 31. That's 28421, 55. Oh, we've programmed it to be slot 1 for everything. It is asking for slot 1 for everything. So what are the slots? What are the textures that we're loading? I don't know. Brick, asphalt. That looks like brick. That looks like brick. Brick messy. Yeah, that looks like 0. Brick messy. Although it could be that brick. It's definitely not asphalt close up, which is what we're asking for. Okay, let's make sure that if we ask for asphalt close-ups, that's what we get. So that's back to make mesh from voxel job. Text equals 0x210. What was it again? $2108421. Whoops. No, thank you. Okay, that's what it should look like. But that's not what we're reading from it. But we're reading from texture grid. Did we not bind it to the right slot? We bound it to 9. I did not bind it to 9 in the source code. I may not have bound it at all. I don't remember. No, I did bind it to 9. What could it be? So one of my superpowers used to be the ability to debug stuff by intuition alone without like debug prints. There was once a bug. I think we were working on Terra Nova. No, I think we were working on Thief. And this friend of mine, Dan Schmidt, who was the project lead at the time, I was in his office looking over his shoulder, and he kind of hit a bug. And we weren't sure what the bug was. And I went back to my office, and I just sat and read the code. And then he, at the same time, went and started adding printfs to the code and running it. And then, I don't know what it was, half an hour, 45 minutes, an hour later, I figured it out, what it probably was, based on the behavior. Like, I just thought about what could you do that would produce whatever the behavior was. And I thought about that, and I looked at the code. Or maybe I didn't even look at the code. I might have just been thinking about it. Because it might have been a system I wasn't familiar with. And I walked back into his office, and I told him what I thought it was. And he said, I just found it with printfs. And it was exactly the same thing that he had just found. So it's not that I don't ever do printf debugging, but that was my superpower. Taking, because it could be a system I wasn't even familiar with, and just guess back, look at the behavior and guess back what it is. But unfortunately, in this case, the behavior is getting all zeros, which is not very useful. Of course, there's that stripe that's not all zeros. That's weird. Am I indexing them a different way? I don't think so, because that stripe is very consistent all the way up. But the stripe also isn't the asphalt color. It's very weird. Okay, well, what if... what if we switch Z to 25, which is the same thing we were... Yeah, doesn't matter. Right, because we wrote out... We wrote out in here 25 plus pos y pos x times 1024. We wrote that out and saw that it was good. So that value is good. That's going into texture grid, which is bound to slot 2. So that's being run here. And that's textures full grid, bound to 2. Then down here, we bind textures full grid to 9. And we've done GL shader storage bit to make sure that that data has been flushed. Plus, we know it's not all 0 because we know it's definitely bound to something because we see it finding something in there. But why is this something it's finding so wrong? Did I get the formula different? It's a texture grid, uint texture grid. Are these relative? No, these are absolute. I am not familiar with different ways to implement TAA. I consider TAA an aberration, a horror, a nightmare. I don't want fake pixels. What would do this? My bit field extract is fine because if we stuff text, it works correctly. These coordinates should be correct because we use the exact same coordinates here. This formula is the same. Not binding the right shader storage is the most plausible explanation. But I just checked that. Why is it not asphalt? What am I missing? What am I missing? If I stuff text, it works. Therefore, this value is wrong. This value seems right. Therefore, reading from texture grid is failing. We're binding texture grid. We're binding it to textures full grid. We're computing textures full grid here. Here. And we're memory bearing here. We're checking in the debug, we're checking the actual texture grid value. And then if we use the shader and force it to the same slot, this should be reading the exact same data that we're writing to debug data. Not that much of it is being written. But it makes sense that it doesn't start until because the building starts a little bit away. So it starts at 4,2, it looks like. So if we go to, or 2,4, no, 4,2. Looks like it starts at 4,2. So if we look at build map, look, it starts at 4,2. No, that's Z height of. Oh no, right, because the debug is yeah. But that's still the Z height is 25. Oh hey, look, there's the isolated value, which is, oh, there's a isolated value. Oh yeah, we do write out special values in some spots. I don't know. I can't see why this would happen. That's incredibly consistent. How does this happen? It's like we're aliasing the memory, or like do we have a different buffer that we're actually assigning the exact same slot to? Texture runs great, shader storage. Let's create another copy of it so it gets different storage just to make sure. Yeah, it doesn't matter. What would do this? How could you have this happen? It just doesn't seem to be the data that we're writing. Oh wait, we have, that was texture runs. We want textures full grid. Does that matter? Where it is textures full grid in both places, right? Yep, texture full grid. If 0, else textures full grid. So we want to replicate textures full grid. Maybe it's not the right size. Looks like the right size. Nope, didn't make any difference. All right. Textures full grid. It's X 256, Y 256, Z 1024, 4 bytes. That's correct. What would do this? What would do this? We're so close to getting this working, because then once it's working, we can actually start building the procedural city, which would be much more interesting. What? What? Well, it's changed, but not how I was hoping. Oh, because it's Z primary. So we need to go that's what, a megabyte. That's not too big. That extracts the X, and then 18 is the Y. This is 256 times 4. And sure, we might as well XOR the Z in as well. So now we're XORing the X, Y, and Z. And that didn't work either. But I'm probably doing the XOR math wrong. Um, this needs to be 4 times because this is in bytes. Invalid size or offset, so something there isn't right. That needs to go 8 times. This needs to be 8 times size attack. This needs to be in bytes though. Let's just hardcode that explicitly. This is 256 times 1024 times 4 bytes. And it's divided by 256 times 1024 times 8 times 4. Still wrong size. Oh, I should see what the value actually is when it dies. Use the debugger. 256 times 256 times 1024 times 4. 26 times 256 times 1024 times 4 over 256 times 1024 times 8 times 4. 32. I is 0. We die. Oh, it's bigger than the staging buffer. Okay, there's the stripe pattern, except it should be it shouldn't only be along the z-axis. It should be along the z-axis and the x-axis and the y-axis. It shouldn't only be on one side. It should be on all sides. So is the bug how I'm setting it, or is the bug in the code that's reading it? Pretty sure that's right. So we're doing all the z-axis, all of the y-axis, all of the z-axis, all of the x-axis, all 8 of the y-axis. So we don't have a bug in computing this. Still has that weird glitch there. Oh, it's interesting. That's not coming through on the other sides. Oh, because I'm writing I. This should be 0x2108421 times. Aha. Okay. So we're getting the X and Y axis, but not the Z axis. Right, because we're forced it to 25 in this. Yeah, okay. So now we should get the checkerboard, that pattern. And we can see this one stripe, and so that one stripe is undoubtedly being written by the code. So if we disable this, if we don't try to generate it from the command list, probably that stripe goes away. Yep. Okay. So this code that generates the texture grid is wrong. It's generating to the wrong spots. This was from hacking it. Check that region is correct. Region, we extract out by discarding the bottom bits. Then we rescaled it to put the bottom bits to 0. We recompute the lengths. This is all assuming that the command is actually in the thing. So this code used to have an if-def for whether to do this thing, to expand it from 8x8 to 10x10. But now what we do is we run this compute shader twice to generate both. We generate both the expanded one and the non-expanded one. And the way we do that is by, when we do the grid, the dispatch grid, we, instead of the Z dispatch being 1, now the Z dispatch is 2. So global invocation ID goes from 0 to 1. And so if it's a 1, we do the expanded range. And if it's a 0, we do the non-expanded range. That way we have both the 10x10 for the occupancy computation and the 8x8s for this texturing step. So why is build texture grid wrong? Oh, because I hacked it. No, we're in the if. We're in the else, which is not hacked. The actual num voxels, the actual size. I mean, maybe this math to compute the XYZ is wrong. So yeah, I didn't review this code, and I guess I should, because I wanted to do all the coding on stream. So this is a code to build the 256 by 256 by 1024 texture grid. But it's only, we don't worry about initializing it. We only need to populate it with the ones that get drawn by the command lists, because we'll only ever query visible voxels which have to actually get set to something. So we're parallelizing over the draw command has a slab, draws a slab. We're parallelizing over the voxels in the slab. So we are doing one SIMD lane per voxel. Oh, I did talk about this a little bit, but so we have to iterate over the command lists for this region, for this 8x8 region, which is that command list that was called, that I just said, it's called to each 8x8 region. We compute how many parallel SIMD lanes there are. Oh, that would be a bug. That would be me testing something. Didn't matter. This is just a timeout. We should bump up all our timeouts now that we've got that loop, the weird timing glitch fixed. We can use higher timeouts. The timeouts are just so that if I screw up the code, the loop always terminates instead of, because if the loop doesn't terminate, the driver resets and actually screws up OBS some. I have to restart OBS. It doesn't break the stream because I have a capture card, and the actual OBS that's streaming doesn't break, but the OBS that I use to transmit to the capture card breaks. So we can just kill this code now. It's not useful. So it's got to be this code isn't right. Is the ID computation right? We step by size. That seems right to me. Am I screwing up how to extract digits? Base Zlin, Xlin, Ylin digits. Is it possible one of those is 0? Well, when we looked at this looked correct. It did look like we were generating the data correctly. Oh, right. Yeah, the 4 was not wrong. The 4 was like looking to see if we'd get a performance improvement by doing more. It's just throwing more threads at the same task. Not clear that it's a meaningful test if the output isn't correct. But that went up to 0.10. 0.08. But maybe a little bit of parallelism is good. Yeah, 0.06. But if you tend to draw smaller slabs, you want a smaller size because you waste less work. Or maybe not, because it'll optimize itself. So maybe setting it to 4 is probably actually the best. So why did that look correct? So it is like, this looked correct in the debug data. So it's like, I think I have Y and X backwards. Build texture grid. Mesh voxel. Y times 256 plus X. Y times 256 plus X. But I don't think that's going to be enough to cause this behavior. Because that's just kind of reverse it. Well, I guess it could, because they're not aligned. Maybe that is it, actually. Okay. Asphalt on this side, but not asphalt on the other sides. And this one still gets the checker pattern. Okay, well, we were doing different than asphalt on some of them, right? Let's set them all to 1 or 2. Yeah, okay, that looks right. So it was just that X, Y, X, which I looked at multiple times and didn't notice it had changed. But we do have some bug up here. These slabs are not getting handled correctly. Okay, there's a few possibilities. One is I was doing some debugging and suppressed some of the commands in some of the logic. I had faster timeouts basically. So let's check that. But it would only be in textures. So it can only be in build texture grid. Or it could only be in build texture grid. Or in the color itself. Could be an off by 1, so that the top and bottom, if they were an off by 1, the top or the bottom would be wrong, and hey, look, the top and bottom are wrong. The top is wrong. The top is off by 1. Okay, I don't know why I have an off by 1. Is it this? Well, let's just write 1 lower and see what happens. Even though I don't see how it's going wrong. Or no, 1 higher. I need to write 1 higher. This will now have two levels wrong. Yeah. I need to write +1. Yep. And now the top bars are all the same. So why do I need a +1 there? It's occupancy data off by 1. is requires a corresponding change in how much data gets dispatched. So we're now dispatching too much data. And that is occupancy bit array. Occupancy bit arrays. I think 64 is supposed to, I think that divide by 64 is supposed to match this. So it was actually, wasn't doing the top half of the map, maybe? As a performance, I was testing performance optimization, maybe. So I think that's actually right now. I think those actually match now. But we still haven't figured out why there's an off by 1. Okay, but I kind of think I know why there's an off by 1. Because the occupancy... starting at low bit, ending at high bit minus low bit. But then, does this generate an off by 1? Which one of these are we? We're running the top loop. If we change this to 1, hopefully we don't get the slowdown anymore. Correct, we don't. Occupancy bit array is the first time, which is 0.07. No, this shouldn't be. No, that's not. It's not Voxel. Voxel jobs from occupancy is this one. No, it's actually split job. It's Voxel job maker. That's the one that's doing that, which is mesh time 1. Voxel job maker. Which is Voxel jobs from occupancy. Okay. So that's, I just said mesh 1. So it's the second number in the mesh timing, the 0.051. Slightly slower. Don't know why. It ought to be faster. Did a lot of engineering to make that faster. But, looky here. Yep, now it's correct. And our total time, 23.23 milliseconds. 230 nanoseconds to build it. Okay. And we don't have holes anymore. Oh, but this is the one that generates the interior. No? How does this not... How is this not generating the interior? Oh, it is. Okay. It's generating very infrequent interior walls. So if we look at the quads, we have 383047 quads. And if we divide this by, let's say, 256 instead. And change this to 256. We'll have fewer false things. I've already forgotten what the quads was. 374777. But it's less efficient because we're using too much shared memory. But so there should be fewer of these internal faces. Yeah, there are a few. But what we'd like to do is get rid of the false ones entirely, and there was a strategy for that, and that was what that W+1 was for. So let's compare 64 and 32. So this is, I believe, the first one. This is the first number. So that's 0.02 with 64. Oh, right. We have to actually match this. All right, with 32, it is 0.10. 64. .07. 128. So 64 seems relatively optimal. So this is spacing them by 64. So we want to space them by 62, which we have code to do. What is this doing? Should this be by times 31? No. If it's 62, yeah, the above below thing doesn't work the way it used to, because we don't go through everything. We only go through the local ones. So below if I understand. if max z equals 62, if I equals 0, is ms. We clear the bottom bit because the bottom bit is meaningless. Else, clear the top bit. This will give us holes again. No, it won't give us holes, but it'll still have the off by 1 bug, I think. So this should get rid of the holes that we've been seeing the whole time. Nope, didn't get rid of the holes. I just still have the off at the top. Okay, yes, which makes sense if it doesn't get rid of the holes. Somewhere we need to be multiplying by max z. How do we determine our z height? Oh, we store the words. We store the words position, not the... We want to shift this one right by 1 instead. So now both of them use the bottom 31 bits. Do you all want me to explain what the heck is going on here? I kind of explained it, but only half-assed. So what we need is the client of this, which is the jobs splitter. It's not mesh from Voxel job, it's the other one. What is the other one? We do occupancy, we do Voxel jobs. Is it mesh? This gets Voxel job storage. Oh, it's this one. Okay. There. No, we still have holes. How does that still have holes? All right, let's do times 30 just to see. Okay, times 30 doesn't have holes. But 31 ought to be the right value. Double check that max z is actually 62. It is. One, two, three, four, 5, 6, 7, 8. We only use these for packing. We don't use V. Oh, but we do need to shift V. Okay, now we have an off by 1 in the text string. Oh, no, we still have a hole. Dang it. And I would expect the off by 1 in the text string. Is there somebody else multiplying by 32 somewhere else? Occupancy bit array. This is the code that's being run. We don't have an if0. Somewhere we convert the split jobs to the voxel jobs. That's here. Apparently. No, it's not here. It's just this code is just carried over from the one that splits them. No, it is here. This is making the... This is generating split jobs. And then this is traversing the split jobs. This only needs to go up to 31. Is iterating over words. So this is just a word count, W. So that looks totally fine. So the job has W shift left 16. We extract W here. And then we'd say Z is W32, 31 plus I. So it ought to give you solid coverage of all 31 slots. And then we just extract X, Y, Z. And that's EWUD, and that's EWUD. I might be too sleepy to think this through. Oh, I see. I had it here. Yeah, that's how I used to do it. Same logic, just it generalized to more words, but generalizes in a wrong way, actually. If the bottom bit is wrong and the top bit is wrong, then the bottom one we shift right, the top one we mask. Yeah, that's correct. To reset these to 3, we should get a double gap. Which I think that is. Why do we not get a gap everywhere? Oh, it was just not visible. Try 30. We want to discard the top bit and then shift down, discard the bottom bit. And then we multiply by 30. Nope, they happen more frequently as expected. And they're computing the wrong thing too. Fun. And this should only need to run 30 bits. I don't get it. I'm too tired, I think. actually make this work right. Right, 30 times. Or 34 times. Just gets a little slower. Dun, 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 dun. Yeah. Z-min, Z times max Z. Max Z is 30. Ah. That's the problem. Not quite. It's part of the problem. Yeah, that was it. Okay, let's put it back to 62. This wants to use 31. This should still be right. That should still be right. This might not be right. Yeah, I think we still want to split this at 32. So I think actually these just stay. Nope, nope, there's some bug there. Z-min, time max Z is 60. So minus 60. Z0 is less than max Z plus 2. Clamp to max Z plus 2. So that's still 0 to 64. Alright, let's just put it back to 30 and make that work. Oh wait, maybe I didn't fix everything yet. Mesh from Voxel job. These. Where's the multiplied by 30 or 31? Did I fix that already? This Voxel job is from occupancy, isn't it? Here it is. 31. I did change it to 31. Alright. Well, since we got that one to work, let's make that one work. So that goes to 30. This goes to 30. This goes to 30. Okay, now it's solid, but we have the off by ones. at both top and bottom, which is a little odd, since I'm pretty sure this should only happen at one end. I believe everything is now being offset by 1 because we're using the bottom bit. So when we generate voxel jobs from occupancy, oh, this is why it wasn't fixed when we need to iterate over to up to 31 to make the maxi work. To make the maxi of 32 work. Okay, that fixes the bottom, but I don't know why that would fix the top. It did fix the top, though. Okay, well. Oh, I do know why it fixes the top, too. Okay. All right, so now let's see if we can get maxi of 62 working again. Maxi of 62, main 62. Okay. I believe that's working. I'm gonna check it in. Powered through even though I was tired. So you may want me to explain what's going on, why it's working, what it's doing, why it's off by 1, or do people just want to be here hanging out? VC6 has a setting that is open most recent workspace, or open the last save whatever. Yeah, open the last week's tools options. Workspace. Reload last workspace at startup. Okay, I want more than two opinions on whether I should explain it or not. Okay, there's a third. Let's get two more. Oh, there's another fourth. Okay. All right. Let's explain it. Does anybody know what's going to happen next? Can anybody guess? Yeah, you got it. Okay. So what we're doing is we're deciding which voxels are visible by building a visibility grid, an occupancy grid, a big grid, 2v6 by 2v6 by 1024, that says whether each voxel is occupied. And then we decide that a voxel should be rendered, quote unquote, is visible, if it is occupied and one of its neighbors is unoccupied. Which we can do by consulting that grid. Now we actually only build little small regions of that grid at a time. At the moment we're doing 10 by 10, then vertically, but let's just look at one column. So what we do is we encode occupancy as a bit. And so we take a 32-bit word. So here you can see this word has 32 bits, obviously. So it's 00110. And then this is the occupancy for a column, going up in space. And there are neighboring ones. And if we do bitwise math, we can determine which ones need to be drawn based on this bitwise math that we went through the other day. And what we're currently doing is in a single shader, we're doing two 32-bit words. And their neighbors. And then we're letting other compute jobs, compute the next ones. But what that means is that it's locally computing this, and it doesn't actually know what's in the next one and in the next one. And then when it looks at the neighbors to decide whether it's visible or not, it looks at remember, this is all turned on its side. So these are actually extending up. So it looks north and south and east and west, which is this way and this way. But it also needs to look up and down. So to determine if this one is visible, it needs to know the value of that. And to determine if this one is visible, it needs to know the value of that. Oops, sorry. To determine if this one is visible. But it doesn't have access to that. It's only computing this thing. Now, what we can do is approximate it, because remember, if a voxel is occupied, we can just draw it. It's an optimization to only draw the faces that are quote unquote visible. Like for example, if you made a big solid thing of voxels and then put a single hole in it all of this computation is going to determine that the faces pointing into that hole are visible. But if the camera can never get into it, they're not actually visible. So it's okay to have faces that are quote unquote visible but aren't actually visible. So a solution to this is that we have these 32 voxels and these 32 voxels, and if this one is occupied, then we just always assume it's visible because we don't know what's here. And if this one is occupied, we just always assume it's visible because we don't know what's here. Does all that make sense so far? So, I drew this too big. So we're going to have a smaller version of it. Right, so this is just this. So then we have another job, as we said, like this. So this is a 32-bit word, 32-bit word, 32-bit word, 32-bit word. So the way we just described it, this one goes from 0 to 31. This one goes from 32 to 63, 64 to 95, 96 to 127. Those are the Z positions because you turn this on its side, it goes from 0 to 31, 32 to 63, etc. But we would like to actually do better. We'd like to say, we'd like to know what the neighbor of this and the neighbor of that up and down are. Now we could do that. We could collect the data for what the neighbor is. But we need to just store an extra 2 bits. We would have to collect that data somehow, and we're doing all these parallel bit operations, and so they would be very inefficient to collect. So what we do instead is we say we're going to compute all of this stuff, but we're only going to generate voxels from here to here because we don't know what the neighbors are for this. We don't know this neighbor. We don't know this neighbor. So we can't generate the visibility for that and that correctly. So we don't. We do compute their occupancy because this one needs to know that one, and this one needs to know that one. So we still want to compute all of those. And what that means is up here, this goes from 0. This is still 32-bit word, but we're ignoring one of the bits in it. And so it goes, conceptually, it goes from 0 to 31. This one goes from 32 to 62, to 61, sorry. This one goes from 0 to 30. This one goes from 31 to 61. So this goes 0 to 30, 31 to 61, 62 to 92, 93 to 123. So all of this crazy logic that I've been hacking on is doing this, ignoring these, rescaling these to not be multiples of 32. And so I couldn't just use the existing pound defines because the existing pound defines were all coded assuming this old strategy that everything was powers of 2. So there weren't any corresponding code to handle that case. I can change all this stuff to not use magic constants by putting new pattern defines that are the magic constants, but they didn't exist in the old code. Any part of that still unclear? So the strategy that another strategy that I'll implement at some point, because this is all storing this stuff in shared memory and sharing this 10 by 10 stuff. So a different strategy that you could do is that each SIMD lane can compute one 32-bit word. It'll track all of the neighbors and itself, so it'll use 5 32-bit words to track the 4 neighbors and itself, and then it won't do the top or the bottom bit, and it will only produce 30. And that was the variant that I was trying to get working in this code, that I did get working in this code. But if you're using a shared memory, it looked like using 2 D words was optimal. And nobody has answered if this makes sense. Why do you remap to T? I don't. And not just skip the 2 end bits. What do you mean by T? I mean, I do skip the end bits, but you have to also renumber everything while you're skipping the bits. So I'm not quite clear what the question is. We'll go back to the code in a second and look at that. But then you won't be able to see the whiteboard, so I want to make sure the concept on the whiteboard is clear. But so the effect here, of course, is that this is effectively computing -1, 30 to 31. This is computing 62, and the next one is going to actually compute 61 and 62, right? Because 31 to 61. The next one was 62 to 92. So this one will compute starting at the second bit, 62 to 92. So these 2 bits and these 2 bits are actually computed the same in different SIMD lanes. They're computed twice, and that's correct. That's the expected behavior. So the thing is 1,000 tall, but each pass is only computing 62 voxels. It's computing 64 bits, but only 62 voxels. So we divide by 62, it rounds down. So we don't quite hit all the way up to 1,024. That's 1024 over 62 is 16.5. So it's still just going to 16. So our actual effective height is only 992. If you do over 30, oops, that actually rounds up to 34. So I'm not sure why it doesn't go to 17. 24. So 32 times 34. Wait, 1024 over 30. Right, okay, so, yeah, so 30 times 34 goes to 1020. But 62 times 17, yeah, it's a bit bigger. But we could round up. We could add 1. Wouldn't hurt. And that now it does go all the way up to 1024. So we say that we're doing 62. So the spacing for every adjacent job is 62, as we showed up at the top, where we said, went from 0 to 30 and 31 to 61. So the next one started at 62 because we're doing 2 keywords at a time. But we want to actually compute 64 bits, and there's a off by 1 issue here. We're going to compute from 0 to 63, but we actually want to compute from -1 to 62, but that -1 is going to potentially mess up the math, so I intentionally just let this whole thing be off by 1, which just makes everything off by 1 all the way, and then which then we fix up in the text string by intentionally displacing all the text string off by 1. So I believe we do not correctly handle data at height 0. I think is anything at height 0 is never getting rendered, and that's okay. We can just have a thing where, yeah, you can't draw the at the very, very, very bottommost voxel layer doesn't draw. That's not a big deal to have that. It's easier than trying to make the negative work through the rest of the math. But anyway, so then this code, I don't know how much of that's visible. If you remember, the bottom word we discard the bottom bit, and the top word we discard the high bit. So this shifts off the bottom bit for the first word, and for the second word masks off the high bit. And both of these leave the 31 valid bits at the bottom of the 32-bit number, which is what you want. You want it to be consistent between both words. And we do all of this after we've done the computation of looking at the neighbors and computing the correct. So the occupancy includes all the bits, and we actually use the neighbors where's below? Oh, below, yeah, it's invalid. We still have to get it so that when you're the first D word looks up at the next D word, and the bottom and the top D word looks down at the previous D word. That still has to get handled, and that's some old code here that was doing that. But otherwise, this is mostly the same. We still save out our position as a word value. We save out the words as jobs, and then when we convert those jobs, we scale the word by 31, not by 32. Because now we're using 62-bit pairs of words, so 31 bits per word. So the Z values are scaled by 31. And we add the 1 to fix up the inconsistency with the texture coordinate storage, because of that way we discard the bottom bit. All right. So now what do we do? I think I actually want to fix the texture. Well, I need to load in a bunch of more textures, and I think I'll do that offline. I need to gather some textures that we can use. And then once I have more textures being used, that I can work on the how we encode the texture, the 32-bit texture number to store the thing. Somewhere in here I have that, I think. Yeah. Maybe at the bottom. Yeah, okay. Strategies use more than 32 textures. If we only want to use 32 bits, hide a bunch of strategies. Here's what I'm currently thinking. So we had this, I had this structure palette idea, which is that you'd have a bunch of custom palettes, maybe one per building, that you get to use in special ways. And I think what we'll do is have that, but we only use that for things that we can't pack into the normal encoding. So multi-format encoding. So encoding 0 will be something. Encoding 1 will be an 8-bit palette selector, and then 6 times 5-bit, 6 times 4-bit, 7-bit palette selector, and 6 times 4-bit. Yeah. Might not even be that. It might just be 8-bit palette index or 12-bit palette index, and the palette might just hard code in what all the sides are, something like that. So you just use this when you need to generate. When the builder reaches the point that it, heck, we might as well just have a single palette. So when the builder wants to build a voxel that it can't describe with the normal encoding, then it switches, it just generates an entry in a palette, and it has to upload that palette and causes an extra indirection. And then the normal mode, I think what we'll do is something like the following. We know that when you make something, a lot of the time, a lot of the faces aren't visible. They're interior faces, like they're facing other adjacent voxels. So a lot of the time you want an exterior and an interior on these sides, and these two sides don't matter. So what you can do is say, 7-bit north, 7-bit south, 7-bit up, 7-bit down. Someone is screaming. And that leaves 4-bit. Select this encoding. So I guess 2-bit, you select this encoding, 2-bit, select this encoding, and then 1-bit. So it could be something like this. Um, but then maybe you have corners sticking out. So then for a corner, you would want adjacent, all four possible adjacent pairs. Like maybe the. So maybe what we do is like, let's see, like, okay, let's do this. We have an encoding where we want the ground to be really flexible. So we have like a 9-bit down. And this is just to do ground texture kind of stuff. So maybe then maybe it's a 10-bit encoding all bases same. Then there's an encoding 1, 2, 3, and 4 that is and then maybe I guess if you're doing a corner, you need to specify north and east, or south and west, or north and west, or south and east, and you don't care what the other opposite side is because you're assuming it's hidden, and so you can just reuse the same thing for them. Or you can have this encoding where you want so you could use northeast and southwest, and then if either, and this is intended for north is visible and south is visible and the east and west aren't visible, or vice versa. And then if it doesn't fit any of those encodings, you fall back and you use this encoding. Something like that. I think that will give us sort of max flexibility. We can have a lot of ground textures that it just always uses the same texture. Well, in fact, we can even do this. 10-bit down, 10-bit north, south, east, west, 10-bit up. So that gives us a lot of flexibility, but not sort of to make sort of isolated voxels. And so then all of them are using 30 bits. Those slash 7777 is only 28. So we can make these 8. Or we could allow more than 4 encodings, because there's a kind of a lack of symmetry here. There's north, south, east, west, and northeast, southwest, but there's no northwest, southeast. And there's a reason for that. It's because we were saying these are really only intended when you only see north and east, or north and west, or south and east, or south and west. And these are only intended when you see north and south, and east and west. This is not actually meant to be creating a block that has one texture on north and the same texture on east, and then one texture on south and one texture on west. But it could be used that way, and so we could introduce another one with the opposite ones. But then you get also the cases of like, well, I want one texture on north and a different texture on all 3 sides, And then so you need 4 different encodings for that. So that would bring us up to 5 more encodings than what we have here, which would be 9 total, which doesn't fit in 3 bits. So I think it's not worth doing. I think you just fall back to the palette if you need to. What is telling you which encoding to encode? There's just a 2-bit. Everything has a 2-bit value in it. And then we'll actually want to make this stuff run efficiently in parallel. So we'll actually want these decodings to be kind of data driven in some way, so that, or code driven in a way that allows the same logic to extract each of them, so that when multiple SIMD lanes are using different encodings, they work. I do want more textures for down than up, so maybe we do 8, 8, 6, 6. Because down is floors, so it's for outside it's ground, but I think we'll only use this one for outside for ground textures. So we really only need it for floor textures, but you have, you know, different colors of carpet and stuff like that. So probably floors should have more variety than walls. So potentially D should actually have more bits than north, south, east, west, but we need both interior and exterior walls types, so probably this is a fair trade-off. All right, but so shall we can't make a city, but we can make a chunk of a city. So let's go ahead and look at that. So create building. We'll have the origin always be the bottom left. Oh, we might as well just do coordinates like this. So we create walls. So we draw a wall along y0. We draw along x0. Draw a wall along y1. Draw a wall along x1. Draw floors. We draw the exterior ceiling. And then we'll draw windows, but we haven't actually implemented creating holes, so we'll have to implement that. We didn't pass that in. Floor height, count. What did I leave out? X0, Y0, Z base. X1, Y1, floors, floor height. Count. P, X0, Y0, Z base. X1, Y1, floors, floor height, count. Oh, it's not address of count. Okay, so we're still drawing the old debug building too. All right, so let's get rid of the old debug building. Okay, we're generating Z fighting, which is not good, because that means we're actually generating the same voxel in multiple places. And we're supposed to be using different textures on the different types of things. which we weren't seeing. So it seems like these floors and ceilings aren't working right. Okay, well, let's skip that. Why are the walls missing now? The old code went from 402 to 240, 180. I got to say +1. But if those are if y1 is the bounds, then it needs to be -1 and -1. Okay. And we took out the interior floor and ceiling, so let's put those back. Still a bug. So wait, did I? This is not Z. This is C base. Okay, and that makes sense. The floor is sticking into the outside, so these need to be +1, +1, -1, -1. All right. Let's have the building start at 2, 2, 5. Go to 80, 80. And have this go out to 250 by 20, and let's have a lot more height. All right. Now let's save that, check that in. And now we have to create the commands to subtract out the windows. And we've already defined that command, but we need to implement it in command list color. The Z height is in data 0, so we don't need any extra commands. Occupancy bit array VRAM. Command erase. So type is command slab or command type is command erase. And we can go all the way up to here in common. If type is slab I plus equals 2. We're going to need to do that regardless, but we don't actually use the data at this stage, so we can just keep going. And then finally here we can say if type equals command erase make sure we didn't break anything. We just insert 0. Oh, well, then we can just do this. Uint insert val equals type equals command slab although this might eliminate some optimizations, but that it might have been making, knowing that what was being inserted was all zeros or all ones or whatever it was. Now we need to actually generate some of those commands. Command erase. Then on each floor, put in windows for now, every 10 feet. And the window is for, yeah. I use an IDE with syntax highlighting. This has syntax highlighting. For some reason, it's gotten lost from that. This should all be syntax highlighted. I'm not sure why it's not anymore. Oh, does this? It's because they don't have preprocessor? Source windows. They don't have preprocessor. I had forgotten that. I could have sworn they did. Yeah, I know. I never used Visual Assist. But anyway, you can see there is syntax highlighting. It's just only for comments and if-defs, except the if-defs isn't working for some reason. I could have sworn this worked. Xs equals x1 plus x0, ys equals y1 minus y0. For x equals, so the window spacing every 10 feet. So that's going to be a semicolon x plus equals 10. Windows, so we'll start at 5. X plus 2 x plus 4 is less than x size. Put erase p comma x0 plus x plus 2 y0 plus 2 3 4. How high should a window start? Let's say 3. X0 plus x plus 2 3 y0 plus 1 z plus 6. And then one on the opposite side as well. y1 minus 1, y1. Okay, there are no holes, but our floors did disappear in this building. Okay, now the floors are not erased, but there's still no holes. Let's make the holes deeper. Still no holes. Okay. I don't think the coordinates here are wrong, so I assume the command is failing. So this insert value thing isn't working right. Yeah, maybe I'm just fooling myself about the ifs ever working. Somebody check OBBG. Somebody check it in OBBG if the if defs or show syntax highlighting. But maybe I'm just thinking of the later VC. Maybe this one never did it. What would go wrong? How would this not work? Oh, I know. Command erase. I renumbered these so that they'd be sequential, so that I could change the math. Oh, hugely slow. But the step that's slow is the texturing step. So that just means make texture is not skipping those and is getting confused by them. So that's easy to fix. If type is command erase, I plus equals 2. Should fix that. No, plus equals 1 because we're already adding 1 there. Still slow. But we do have the holes. Command list, I++, type is command slab, type is command, oh, we didn't renumber this as well. This should be in a common file. Okay, now it'll be fine. Yep, okay, super fast. And yep, look, we've drawn some holes in our windows. All right, so the window height obviously is wrong. These should go from 4 to 8. How much tall did we make them? Did we make them 12 tall? We made 12-foot ceilings or 11-foot ceilings. Floor height. Oh, so they should go up to floor height -3, let's say. And you can see that the measure has gotten a lot slower now that we're actually doing real work. Right, like they used to be it used to total up to 0.25 or so, and now it's totaling up to 0.5 or so. Which is all fine, it's as expected. Okay, so then we want the walls on the opposite side. Change all the y's to x's and x's to y's, and then we'll swap them. Yeah, the mesh is it is converting it to a mesh, but it's doing it on the fly. Uh, it's caching it, but we're rebuilding it every frame anyway, just to debug the performance. But it's meant to be cached. It's meant to be built on the fly as you move around and then cached. So there you go. There's the beginnings. And then we can say that the window spacing we want to do it like this. Floors in window bottom window top window spacing window width window spacing. So then we say window spacing over 2, because we're computing the center point of each one. Window width over 2 plus 1 plus 2. Keep it from getting too close. The start will actually be window width. No, the start will be 2. And then this gets window spacing. Zero equals window spacing over 2. W1 equals window spacing minus W. No, window width. Call this W top, W bottom. This is minus W0. Oh, these don't need to be this extruded thing anymore. So W bottom, W bottom. W top, W top. W1. So this building will get the old spacing of, I don't remember what it was, 10? What's the order? Bottom top. 4, 2, 4, 4, bottom, top, width and spacing. Width was 5, the spacing was 10. And then this one gets nearly floor to ceiling things, but narrow and spaced wider. And I've only done the X's, I haven't done the Y's. Yeah, they start a little too close to the edge and they're cutting a hole at the edge. Yeah, but now they're narrower. They need to start width over 2 plus 2. That was me falling asleep for a second there or something, zoning out. While going, I feel like I didn't finish doing this processing because of that. Maybe I did. Yeah, so there you go. Oh, and color is really slow now too, because there's a lot more commands. And I need to find a way to make it more parallel. It's not running very much. The culling, the cull job is that it's just only doing 4 times 4 times 2, 32 jobs, and everything has to wait for the cull system to run first. So that's probably where that performance is going. Maybe the fact that stuff has to wait for it, I'm not sure. And that it can't get very much parallelism. Yeah, because every lane is computing a separate command list, and we only need 32 by 32 of them. So if you have 32 lanes, I guess we could do that. Well, that's not going to help. It's already splitting it. We need more SIMD lanes to run. We need more work. How can we parallelize this work? Maybe we just split this across frames. Maybe we run the color on one frame and then run the other stuff on the next frame. So that stuff can overlap with the color, because it'll be processing at different frames. Culling work. But anyway, all right, I think that's a good stopping point. We got the beginnings of ProcGen working here. I think I want to do one other thing, which is mesh from Voxel jobs. What do? We make voxel face pair. We store let's store 12 bits for each texture, and then also store an offset. texture U, texture V. And then the voxel vertex shader needs to extract that data. Where's that data? It's data.x and data.y, I guess. So where does data.y get used? It's down here. To U equals float bit field extract data.y for 4 float TV equals float bit field extract data.y. And then we want to say TU TV 4.0 TV equals 4.0. Over 4.0, then we can put that in a thing. TU plus S, TU plus TV plus S, TU plus S. This is only going to be right on one side, but we'll worry about that later. And then when we build that mesh from voxel job, we need to pass in TU TV to make voxel face pair. So we use y and 3, no. So all I'm doing is I'm trying to stretch the texture. Right now, the texture covers one voxel, and I'm going to change it so the texture stretches across 4 voxels before it repeats. So that it can be a little less repetitive. What was the bug here? I assume it's int to uint. Oh, no. Bitfield extract. What? Did I even use bitfield extract? No, I did. Bitfield extract. Bitfield extract. Okay, so on one face, these will be discontinuous on one side, but on the other side, they should be continuous. No, they're not continuous on either side. Okay, what about these ground textures? Nope. They're continuous in one axis, but not the other. No, that's a discontinuity too. And what about from the other side? Also broken. Nope, I don't want to stop the debugger. I want to stop that. That has to come from 28. That looks like it might be continuous. That's incorrect, but maybe the bottom is continuous. Nope. That's wrong there. And that's wrong there. This might actually have a seam in it too, and I'm just not seeing it. Also, am I generating interfaces, or is that the window? That's the window, okay. So I should switch to a texture that's more obvious when it's broken. It's funny how I don't see the edge. I have to really concentrate to notice it. Okay, so we use the XY coordinates, which means we could just use the XY coordinates actually in the thing, but this is a little more flexible. But we really want to actually store separate for each face pair probably. And if we only use 2 bits, which is what we're doing right now, then we could actually store 4 values. So we could store values for both pairs. Well, let's just get one pair working, one side working. TU TV, TU plus STV, TU plus STV plus S, TU TV plus S. I believe that is all correct. I think that one I did correct. So it's got to be in compute measure. Mesh from Voxel Job. The first one is the X pair, which is the faces on positive and negative X. So their X values are constant. So they should, texture position should vary with Y and Z. That looks all correct to me. TU and TV extract the same bits. I assume that was the old bug that I fixed already. Yeah. Okay, let's set it to 0 and see if it's different from that. Yeah, there we see that really repetitive look. And I think we don't see that if we do this. Yeah, it's not as repetitive. It's just wrong. Okay, if we only set one of them to 0, can we get the repetitive look? Yeah, you can see it repeating horizontally. And if we only set TV, see it repeating vertically. Yep. Okay. So if we don't set either, it seems to be doing the right thing in terms of not repeating, but it doesn't match. Because the vertex positions don't match. What are the vertex positions? Yeah, it's being rotated arbitrarily because of this, how these numbers don't start don't go in the right order. So I need to repack these numbers I need to recompute these magic numbers so that these are in the right order for the texture coordinates to match. All right. So we want to start with the winding. I think I'm too tired. So I think we'll stop. So any final questions before the stream ends? I type that in so it'll compile error, so I'll always know where I was. Anybody? Anything? Oh, yeah, you said that. We'll just do a quick fly around of the current thing again. Oh yeah, okay. Let's do one thing first. Let's make it so that the windows have a different texture on them, the window sills. So oh no, we can't do that because we don't actually support interior or exterior yet. We have to add that support before that'll happen. So never mind, we won't do that. All right. Final call for questions. Yes, that old trick still works, but modern compilers might give you a warning. Certainly, static analyzers will probably, I'm sure, will warn. I mean, for some reason, even back, I think even when I won the IOCCC, I think they were undoing that change. So they must have had a compiler that it didn't work on. I seem to remember that they changed that in my code. Which was the 90s. I use arenas in code that where that's appropriate. Uh, but the best case for arenas is code that goes through like really dramatic separate phases. In a game, if you have like allocations that only last for the frame, then that may be reasonable. Um, you could have a frame arena, but uh, that could also cause you to use more memory than you need. Just not as much of an issue on 64-bit, but it's an issue potentially on 32-bit. Um, but I don't even do that much malloching, do I? I mean, they're just arenas don't exist by default, and malloc free does. So all the STB libraries just use malloc free because it's there in the standard library. Like the rules for what STB does is very different from the rules for what I do in my own code. Like I do have an arena type in stb.h. I just don't know when the last time I've used it was. It just doesn't. If I'm writing quick and dirty code, oh, I guess it got deleted. I think that's, yeah. Parenthesized ifs have been removed. I just never used it, so I got rid of it. That you just saw it in there. In the STPDS hash table, there's an arena mode for that where it stores the strings that it's using as the keys in an arena. Or it can you store them with malloc, or you can have to manage them yourself. And if you use the hash table with the arena, then as you add and delete items, the arena keeps growing. Uh, may even add the same string multiple times. If you add something with a string and then delete it, then now the string has gone from the hash table and it doesn't actually know that it exists in the arena because it doesn't keep a separate hash table to access the hashed strings. So the upshot of all that is that you'll keep adding that string to the arena every time. So you really only want to use the arena when you're doing a mostly add only dictionary hash table. But yeah, in games, often the malloc free have a longer lifetime, have weird overlapping lifetimes, so you can't rely on arenas. It's not like a compiler or something where there's these distinct phases that you can potentially use an arena. Hi and bye, because we're wrapping up. Fuck you. You can get a ban. Don't know why people insist on wasting other people's time like that. Don't need to tell everyone your opinion. You can just keep your opinion to yourself. Nobody needs to know your opinion. All right. I guess that's it. Thanks for being here. And I will see you all next time. If I can remember which mouse to use. Oh, yeah, and have a good weekend. Thanks for being here on the weekend. Crazy. All right, bye-bye.